Evening, everyone. My name is Ankit. Today, I'll be presenting my project on comparative analysis of machine learning models for phishing website detection. Uh, let's start with it. So, my research question, which I was studying, was which supervised machine learning model out of logistic regression, support vector, and random forest can provide the best balance of accuracy and reliability for detecting phishing websites based on the UCI dataset that we are using. Okay, so introduction. Phishing websites are becoming harder to detect because they keep changing their URLs and host settings to bypass blacklists. In this project, we have explored whether machine learning could do a better by learning the hidden patterns in phishing URLs. We compared three supervised models, as we said, logistic regression for our baseline, support vector for more complex patterns, and random forest for high accuracy and robustness for to tackle with noise. And let's start with our main. So dataset preparation and loading and preparation. We used UCI phishing website dataset that contains over around 11,055 labeled entries. So each entry was pre-engineered features, came with pre-engineered features, and there were 30 pre-engineered features like URL length, use of symbols, SSL certificate, status, domain, age, and many others. So we mapped the label so that zero represents phishing and one represents legitimate sites. One advantage of this dataset, it was already clean. There were no missing values. There were nothing. You can say there was nothing any kind of noise. So start with the splitting and scaling. So if as you can see on the screen, we split the dataset into 70 for training set, and 30 for testing using stratified sampling so that both have so both sets can have the same phishing legitimate ratio. So if, for example, if in the first 70% of the training for the training in complete data set there are 55 phishing websites and for 45 legitimate, but in this case, even after splitting it, the ratio will remain the same of 55 and 45. For LR, we applied standard scaling, but these models are sensitive. That's why, to avoid the data leakage, scaler was fitted only on the training set, then applied to the test set. Okay, let's move on. So the model setup and hypertuning. Okay, as you know, we split the data in the previous slides I have shown you. Logistic regression was our starting point. It's fast and easy to interpret and gives a solid baseline. SVM was chosen because of it is great at handling non-linear boundaries, especially with RBF kernel. Random forest was selected for its ability to handle the noisy data, as I said, and modern complex relationships and provide feature importance scores as well. Then hypertuning, instead of using default settings, we used grid search CV and five-fold cross validation. This method allowed us to test multiple parameters and pick the ones that gave the best accuracy on the training folds. This ensured that our final model was are the best possible version of before evaluation. Confusion metrics. Let's start with yeah. So confusion metrics. Looking at the confusion metrics, logistic regression had the highest positive rate, which if you can see, there were 134 legitimate websites that were flagged, and for phishing it was 101 false negatives. SVM reduced these errors, but I think so. Random forest was the best because it only gave 62 false positives and 32 false negatives. Okay, next move on to precision and recall. Yep. Precision and recall curves show how well each model separates phishing from legitimate. And if you can see, random forest has the highest AUC as compared to the logistic regression or SVM. SVMs came close, but logistic regression, because it's a linear based model, LR lagged slightly behind, but it wasn't very far. Precision recall confirmed that RF and SVM maintained a good balance between catching phishing sites and avoiding false alarms, as you can see on the screen. And let's move on to the next slide. Learning curves. So learning curves tell us how performance change with more training data. So as we said, like in training data, we only took 70% of the original data set size. So all models were trained around on 70% of training data set, meaning they were already performing near their best. And SVM and RF, if you can see, were like very close and between training and validation score. But logistic regression was lagging a little far behind. And I think so. But if you, as you can see, Random Forest did the best in performance measures. So yeah, let's come to the final conclusion and the summary. As you can see, RF was our best model. Around Random Forest had the best performance score in every aspect. For if you take accuracy, precision, recall, F1 score, or AUC, it completely crushes all of the others. SVM came close, especially if you can see that, but logistic regressions, as you can see, it was lagging far behind because it's a non-linear, and it was our baseline. And so that's it from my side. And in conclusion, I would say overall, Random Forest is the most accurate and reliable model for phishing detection in this setup using the UCI dataset. If if tested on newer or latest phishing dataset, because UCI is a little older. It is not too old, but it is a little older, and as you know, there are a lot of cases, and phishing websites are becoming really advanced and growing in months, not even years now. And if tested on newer datasets and extended towards models like XG Boost or Light GBM, performance could improve even further, and we can see a lot of different parameters that can be added to this. And a feature importance analysis could also help build a faster and lighter detection system for deployment, especially in the real world. So that is in for the future work, and this is in conclusion. Uh, Thank you.